So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you know, that this is an online platform for the civil structural engineers to interact with us and ask their doubts or queries that they may have related to RCC or steel design concept or any project that they are doing or construction site issues that they are facing. So, this is the 59th such episode that we are conducting, and let us start with today's session. So the first we'll be taking the queries from the Google form, and then we will take the queries from the live audience. So let me share my screen and we will begin. So is the screen visible now? Okay. So the first query is from where is it? First query is from engineer Dhruv Jyoti Ghosh. He's from Siliguri and he's an independent consultant. He wants to know uh, I want to know how to design PEV shed consisting of rafter and purlin over RCC column joint for construction of mall cum multiplex. That is type of joint to be provided, moment releases, and whether arch shape required or not, bottom chord required or not for width of structure more than 15 meters. Seismic zone is Siliguri. So he has also shared one image. I'll just let me just open that image. Mm. Okay, no image has been shared. So, how to design PEV shed consisting of rafter over RCC column. So, what he's saying is that he has a RCC column. I'm trying to show you an elevation, and then he wants to construct one shed over it. Type of joint to be provided, moment releases, and whether arch shape required or not. Width of the structure more than length. I think what he's saying, this is 15 meters. Length is 21. So I think the other direction is 21 meters. So first question is asking whether an arch shape should be provided, or so see, three options are there. Either you provide a R shape, or you may provide a, a truss shape. You may provide a regular truss also, or you may provide only the rafter system. All right. So in rafter system, it will be something like this. So the shape will depend on the architectural considerations and the overall planning, and as per the main agency involved who is doing or who is coming up with this planning, the shape will depend on that. If you ask me, arch shapes are always better. Uh, arch shapes are better, but remember that in case of arch shapes, they apply or they lead to lot of thrust on the columns. So then the columns and footings have to be accordingly designed for that thrust. So that will be the problem with arches. So whatever shape you come up with, that has to be in consultation with your client and whoever is the person in charge of the overall planning and aesthetics of your structure. Okay. Moment releases, again, it will depend on the type of system that you are coming up with. Let's say if you are coming up with a rafter system, I am taking short steel columns over here for better connections. So if you are coming up with an rafter system, you may go for pin support. Okay, so that moments are not transferred to the column. Of course, the thrust, lateral thrust, will lead to moments, but there is no end moments that are getting transferred. So if you are going up with this type of system, then you may provide pin supports, but of course then you will have to check for the lateral deflection of this rafter system. In the same system you can go with uh, moment connections also at the base. That is also possible. If you are going with a truss system, in truss system usually you may prefer to have a pin roller support arrangement, so that the internal stresses in truss are not very high. So if you are planning to go with a truss arrangement, you may go for a pin roller system. And if you are going with a arch, again you may go with a pin arch, but then that pin arch will create thrust. So sometimes people go for a pin roller, but pin roller will mean that this arch will have a lot of lateral deflections. So if you are going with pin roller, maybe you will have to think about tie. Okay, bottom chord. So better to go with a pin, and better to avoid the tie, because tie was your third part of the question, a bottom chord. So if you are providing arch, basically you will provide arch for the greater clear height. Now, uh, with an arch, a bottom tie would not look good. So try avoiding the bottom chord over here. And if you are providing arch, just stick to the arch shape with a pin support. Seismic zone is 4. So in these steel structures, seismic zone might not be very important because there is no additional load acting as such on the steel structure. Of course, you will take some live load, let's say 75 kg per square meter, but then there is uh, no live load for a sustained period of time. So live loads is not a problem. Dead loads are also pretty less on this. So seismic loads are not that important as compared to the wind loads. So you may be in seismic zone 4, but seismic loads as such will not be that high as compared to wind loads, which will be critical and govern your design. Okay. So this was his query. Next query is from engineer Deepak Patel. He's from Ahmedabad and he's an independent consultant. Uh, he's asking, and he had shared one image also, so I'll just put that image also over here. He's saying, sir, सिंगल पाइल एंड डबल पाइल में पाइल कैप सेटलमेंट बहुत ही ज़्यादा आ रहा है. सॉइल की प्रॉपर्टी असाइन किया फिर भी जो सेटलमेंट आ रहा है वही लेके चल सकते हैं? Question mark. So see, what happens in safe is that when you have a single pile cap, and let's say this is your pile, and then there is one column above. This black line is the column above, black box is the column above, and this was your pile, and this is your pile cap. So what happens usually is that we only assign stiffness to the pile, isn't it? In safe, what we will do is that pile we will model using a spring, and then you have modeled shell. So this is your shell element, and then there is a column on it. So what happens with these cases is that if there is a movement in the column, what will happen? There will be unrestrained deflections in your pile cap because of the software issue, that there is nothing that is restraining this pile cap from the uh, rotation, isn't it? You only have a single spring assigned at the pile point, and because this was a single pile cap, only you had this. So as long as your loads were perfectly axial in the column and they were completely concentric with the pile below, you won't face this problem. But as soon as you have any moment in the column, or for that matter any shear in the column, then you will get unrestrained uh, deflections. Okay, same thing you may find in a two pile cap also, that if you have this kind of a pile cap, and let's say you had a pile and this was your column, and suppose the actual movements were about this axis. Now about this axis again, what will happen, that you have modeled the pile with single point springs. So again this pile cap has no restraint, so to say, for movements about this direction in the column. So again you will see very high deflections as you are getting over here. So what do we generally do in such cases, that it is good to provide soil stiffness below. Okay, it is good to provide soil stiffness below, so that way it will try to balance out some deflections. But even then you may get large deflections. Why? Because generally we provide very small soil stiffnesses are provided. Okay, because you don't get large bearing capacity of your soil at the pile cap bottom level, so you still may get very large rotations, and because of that large rotations you may get very large deflection values. So this you need to check first of all. Okay, I mean this problem you need to understand. Now generally what you can do is you can tie it up with some tie beams. Generally, a single pile cap and double pile cap are usually tied with some tie beams at the plinth level or at the ground level. Okay, number one. Number two is that you can assign the soil supports. Again, as I just said, even after soil supports, you may still get some large deflection values because the soil spring stiffness assigned is pretty low. So even after that, if you are getting these high settlement deflection values, you just need to just check, and if that is the sole reason for which you are getting the deflections, it's okay to ignore it also, because you know why this is happening. Okay, you know why it is happening. So if at these corners or at some points you are getting very large deflections, uh, I would say take an engineering judgment and ignore it, but please ensure and check why that deflection is coming. Okay, and as I told you, if it is due to just because of the configurational issues, it's okay to ignore. So these things, assign soil stiffness below your pile cap also. Additionally, you may translational assign translational restraints at the corners, just the corners, if required, because anyway your pile is not going to slide as such. So a pile cap system is not going to slide as such. So you may consider assigning corner springs, translational restraints, and additionally consider adding the tie beams at plinth level or ground level. Even after that, if you are getting settlements, it's okay to ignore after finding out properly the reason for this type of settlement. Okay, all right. Then the next query is from engineer uh, Rohit Kashyap. He's from Guwahati, and he's saying, I have a building with shear walls and columns. I have a building with shear wall and some shear walls and columns. When I'm modeling in ETABS, 92% base shear is taken by shear wall, only 8% being taken by columns. As per IS 1893, frames should be designed for at least 25% of lateral forces. Stiffness modifier is this, so very less base shear is taken by column. I want to increase the base shear taken by columns. Can I use stiffness modifiers? Then stiffness of it will attract due to less reinforcement. Practically similar, increasing forces and also take higher base shear. Is this okay, or I have to? Also, can you show how to check how much forces shear wall is taking and how much columns is taking? And is it necessary that frame should take? So he's asking question about the uh, dual systems, dual systems, or even in shear wall with column buildings, you are required that whatever shear wall is taking, that's fine. But additionally, the perimeter frame, as per the codal requirement, the perimeter frame should at least take 25% of the earthquake forces. Okay. That is the requirement. And generally, because the columns are not stiff enough, you will see that the majority of shear is taken by the shear walls and very little by columns as such. The code wants you that 25% of the earthquake forces or the earthquake effects, it does not write base shear. As far as I remember, code does not write base shears. It writes 25% of the earthquake effects should be taken by your perimeter frame. And there are two effects. One is the moment, one is the overturning moment, one is the base shear. So base shear will be taken very less by the columns because of very small cross sectional area. It offers very less stiffness. So majority of the base shear will be taken by walls, as is your case also, that 92% is being taken by walls and only 8% is being taken by columns. So my suggestion to you would be that don't play around with stiffness. That will be too complicated, and then it will change all the behaviors and it will change the forces in other elements. So don't play around with stiffness. What you can instead do is that, let's say this is your main model. Okay, this is your main model. Now in this case you are getting 8%. Okay, you're getting 8% as the base shear in the columns. Now you had to ensure that your perimeter frames are taking at least 25%. So what you do is you save as, and just save it as a new model. Let's say a new model for perimeter frames only. New model for perimeter frames only. So now you have got a new model. Now what you do in this model, you will just take care of the perimeter frames design. Now you wanted that they should take 25%. Right now they are taking 8%. So now you can do some jugad work. And what that jugad can be, that maybe in the load combinations involving EQ, maybe in the load combinations involving EQ, you may increase the scale factor of EQ forces. So for example, you had a load combination 1.5 dead plus 1.5 EQ, suppose, or zero point 0.9 dead plus 1.5 EQ. Now, this, you saw that it was reaching only 8%. So if I want 25%, what I can do? So let's say 25 upon 8, some 3 point something. Okay. 3.16, some whatever. Okay. So now, as a jugad, you can just multiply this EQ by an additional factor of 3 point something. Okay, in the hope that now the base shears, because now there is a factor of 3 point something, the 8% base shear touches around 25%. And then in this particular model, you only design the perimeter frames only. You don't design shear walls or any other element in this, only design the perimeter frames. So in this manner, uh, using a new model, or saving your original model as a new model for perimeter frames only, and as a jugad work, by multiplying the EQ load combination by an increased factor, you can take care and design the, I mean not take care, you can design the perimeter frames for it. So this is one of the ways in which you can do. Playing around with modifiers will be complicated, because then it will sort of change the forces in other elements also, which you don't want. So it is better to do like this. All right, is this clear? Okay, this is one of the options that you could use. Mr. Rohit Kashyap is saying, why only perimeter frames and not all columns? I think that is how the code gives. Just if I remember correctly, it is for perimeter frames the requirement, or is it for all columns? I'm not fully remembering, but what I can, let me just check. If it is for all columns, then it will be this method. You can just apply for all columns. There's no problem. Flat slab structural wall system. I'm just reading from the code. Perimeter RC frames, they are saying. Perimeter RC frames. Yeah. So, okay, I hope this is answered. Then we have next question from engineer Sadharm Koot. He is from Pune and he's a working professional. How to give reinforcement detailing for openings in slabs. So around openings, what happens is that the stress distribution changes and the behavior of the slab may also change. For example, if this was a one-way slab, essentially if this was a one-way slab, let's say having only these as support lines, I'm showing you the plan view of course, and you had an opening over here. Now what may happen in this region of opening, that in this case the slab was one way, but suddenly here this slab behavior may change and the reinforcement has to be therefore carefully looked into for regions around openings. So wherever you have got openings at these corners, there is a problem of increased stress distribution also. So first of all, you find out what is the reinforcement requirement around the openings and how that opening position is changing the behavior in the slab. So such a thing you can do, let's say in ETABS if you are using, by modeling the slab and correctly modeling the position and size of the opening, and then checking your M11, M22 moments, and then accordingly finding out the reinforcement first of all. That is the first, what should I say? That is the first thing you need to do. Secondly, and this is just not for one-way slabs only, for flat slabs, for two-way slabs, you have to be careful wherever there is an opening, because any opening location will affect the overall load path in your slab systems. So that is the first point that you need to take into account. The second thing you need to be careful is that if your slab is part of lateral load resisting element, let's say there were this slab had to take large earthquake forces and there was whatever system you had provided, and then there is a opening also over here. So because of this opening, now what happens, that even lateral force transfer is affected. So like now this slab has to take lateral forces, because that is how the vertical loads are usually transferred. Sorry, the lateral loads like seismic and wind are usually transferred from slabs to vertical elements. So now around the openings again there will be problem because the load path breaks, isn't it? Load path breaks. So then in such cases you have to again correctly or carefully look for these regions around the opening and study their load path, especially if the load, let's say lateral load is in this direction as I'm showing you right now. Lateral load is in this direction, let's say, let's call it as EQX. So then these elements are important and we usually call these elements as the collector elements. These become my collector elements. So I need to see what sort of design and reinforcement I need to provide. So this again you can do it by modeling this correctly in your software like ETABS, checking for the moments and accordingly providing reinforcement. So these become your collectors and these orange things are called as cords. So carefully first of all the reinforcement has to be checked. So it can be a case of lateral loads or it can be a case of gravity loads. Then the third point is that around the openings at corners there is large stress distributions. So therefore, whatever reinforcement you have calculated for gravity load or lateral load, you need to not stop the reinforcement over here, but continue it till at least Fi. I mean, sorry, continue it till at least LD distance from the corner. That means, let's say whatever reinforcement you had worked out, you continue it till a distance so that adequate development length is provided. Okay, so take the reinforcement till LD distance. In some cases the code suggests you to take it till 1.25 times LD also. So in a few clauses in the American code, let's say suggest you to take the reinforcement around the opening still 1.1.25 times LD also. So it depends, but the basic principle is that you need to have the reinforcement developed till LD at least around the openings. And the reinforcement arrangement could be, if I'm showing you a cross sectional view now, so the reinforcement arrangement around the opening could be that I provide additional bars like this around the opening, and maybe if required you can just provide a small ring at certain distance also, and then this can be extended LD beyond the corners. In some cases, if you refer to SP34, it also further asks it further asks you to add a diagonal reinforcement also around the corners, so that the corner stresses are taken better care of. So this is another arrangement that your SP34 suggests around the openings. Okay. So these were my thoughts about reinforcement detailing around the openings. Then the next query is from engineer engineer Rajendra Kamble. He's from Sangli and he's a working professional. He is asking, uh, in water retaining structures, criteria for minimum reinforcement as per IS 3370 is this. Query is it total reinforcement of vertical plus horizontal for both face? Now, first of all, it's not 0.35, it's variable. It's not 0.35, it's variable. You refer to IS 3370 part 2 2021, and there's a table 5, I think, table 5 for minimum reinforcement percentage. So refer to that table. It clearly says that whatever reinforcement you calculate is in both directions. It is in both directions, and this reinforcement that you calculate in both directions has to be within each surface zone. And then the definition of surface zone is given for different thicknesses of your wall or slab or raft or whatever your element is. So as per your design element thickness, the surface zone is given. So it's quite clearly mentioned in the code IS 3370 part 2 2021 table 5 that the reinforcement has to be in both directions, and then within each surface zone you have to provide this specified reinforcement percentage. It's not 0.35, it's variable, and it changes as per the wall thickness and tank wall dimensions. Okay. Yes. So you better refer to this, and then if you have any doubts, uh, you may ask. The next question is from engineer Anukul. He's from Delhi, and he's a working professional. He's asking, let me just copy his queries. So his query is, oh, long query. Question 1. So camber provision in long span beams. So he is asking, uh, I am designing a commercial building where the primary beam span is 12 meters. During the serviceability limit state check, the analytical deflection is about 56 mm under the governing load combination including seismic. To satisfy the 456 deflection limit, the beam size increases to approximately this, which is not economical. I was advised to provide camber in the beams. As per CPWD guidelines, a camber of 4 mm per meter can be provided. Could you please clarify? Is it acceptable to use construction camber to control serviceability deflection in RCC beams? Yes, camber you may provide. Camber is a practice that you may give, but remember that the camber will only take care of the immediate dead load deflections. Okay. But yes, camber you can provide. Should camber be modeled in ETABS? I don't think camber should be modeled, because that camber that you provide, generally it's only for the dead load part of the deflection. Okay. So assuming that the dead load deflection comes into being just a few days after the beam is constructed, let's say. So immediately after the beam is constructed, your dead loads will come into picture. Of course, there will be no brick walls by then, or the floor finishes by then, but at least the initial dead weight will come into picture then and there itself. So I would not say it may be required to model the camber in your analysis process. And as I told you, as far as I know, you are only allowed to take the camber for the dead load part of the deflection. In practice, is it better to rely on camber or increase beam stiffness? So as I told you, camber can only be relied upon for dead load part. But what I can see over here is that already you are getting 56 mm deflection. Now I'm not sure that is it the short term elastic deflection that you are getting? I mean, how have you found out this deflection? Is it the short term elastic deflection? That means your normal dead load plus live load model. Uh, is that the case for which you are getting deflections? Have you assigned any uh, or have you done any ICR calculations, or have you checked any long term deflections? So I'm not sure what you are doing and how this 56 mm you have got. But assuming that you might have gone with the normal process of short term elastic deflections, and if you are getting 56 mm, that already is quite a lot. Okay, Mr. Anupul is adding over here short term. So is it without modifier? I mean, there are no, just your normal model without modifiers, right? I am assuming it's only your normal model, just your normal ETABS model you might have prepared with modifiers. So usually for deflections, modifiers are not there. What you do is you remove the modifiers, make a separate model, let's say. And I'm talking about the gravity deflections right now. I'm not very worried about the seismic related deflections. So remove the modifiers, make a model, check the short term elastic deflection. That multiplied by at least 2 to 3 times will be your final long term deflection with creep and shrinkage effects. And that value you will have to check it with respect to L upon 350. So already I can see that this is quite a lot of deflection that you are getting. Okay. Your code allows you only 20 mm, and already you are getting 56. It's okay, it's for modifiers, but even if you were to remove the modifiers and do the short term, sorry, find out the short term elastic, and then assume it that the final long term deflection with creep and shrinkage effects will be almost 2 to 3 times of this value. So already you're looking at quite a large deflection in your beams. All right. So in such cases, my suggestion to you would be to think of going for PT beams and try to control the deflection part by pre-stressing. All right. So that is one of my suggestions, because of the large deflections that you're getting, that and because of the large spans that you have, that try to involve pre-stressing in this type of situation, because you want to control the deflection. Okay, deflection is a main issue for you. The flexural criteria has been taken care of. So think about this, that is it possible for you to include the uh, pre-tensioning aspect in this type of beam. Okay. All right. Then the next query is ETAPS auto wind load method. ETABS provides two options for auto wind load generation, diaphragm based and shell based. Could you please advise which method is generally recommended and why? Do you ever verify ETABS auto wind loads with manual calculation? I have not used auto wind loads in ETABS because anyway the main thing is to calculate CP, CPI or CF, whatever is applicable. That ETABS is not able to calculate anyway. So what ETABS at the best is able to do only calculate the PZ for me or PD for me. So that is not a big deal in any manner as such. So I'm not very inclined to calculating the wind loads using ETABS because the main challenge is in calculating the CPE, CPI, CF, which anyway we have to look into the various tables of IS 875 Part 3 and calculate. So I don't go for the ETABS auto wind load. But if you are going and if you want to compare between the diaphragm based or shell based, so I think for RCC buildings, uh, where you have a, let's say, a RCC slab with vertical elements and beams etc connected to it, you may go with diaphragm based method or shell based method. Both will give you similar results. But if you have a, let's say, a steel structure without a slab, or let's say you have an industrial shed like structure, okay, again without any slabs, or if these are the types of structures you have, it is better to go for the shell based method where you model a shell on the elevation and apply the loads. So as long as you have a thick slab, diaphragm based method can be adopted. In that, in fact, either of the methods is not a problem. But you, if you have if you have structures where you know that you don't have a stiff enough RCC slab, or where the load distribution will be mainly governing the design of your roof elements or wall elements, then it is better to go with shell based methods. Okay, all right. So this was Mr. Anukul with his query. Then the next query is from engineer Balaji, and he's asking, uh, while designing PV structures, sometimes, so engineer Balaji is from Chennai and he's a working professional. His question is, while designing PV structures, sometimes people go for utilization ratio up to 1.15, instead keeping below 1. Is that fine? Not as per the code, because code clearly says that your capacity should be greater than demand, and utilization ratio is nothing but a ratio of demand upon capacity. So if your utilization ratio is greater than 1, it indicates that your capacity is less than demand. So as per the code, your utilization ratio should remain less than 1. So if you are going for any value greater than 1, technically it's not allowed. Now why do some people do it? They may have their own reasons, because they think that, let's say, this is for a seismic combination or a wind load based combination, and wind load, you won't get that amount of wind loads, or you are not expecting that amount of seismic loads, or you may say that the 75 kg per square meter live load will not be experienced by the structure. Whatever might be your reason, the designer may choose to go for utilization ratios greater than 1. But technically, if you ask me, code wants your capacity to be larger than demand, so UR has to be less than 1. Second point is, deflection checks are different from utilization ratio. Deflection checks are serviceability based checks. Utilization ratio is the ultimate level check. There is a possibility that your utilization ratio remains less than 1, but it is failing in serviceability checks, or a member that is passing in serviceability check may have utilization ratio more than 1. So either of these two cases may be possible. So both these aspects, that is the serviceability design and the ultimate design, have to be checked separately, and they have to be within the codal limits. Okay. So the effect of deflection is not considered in the utilization ratio checks unless you have not run a p delta analysis, let's say. Okay. Yeah. So both are independent actions and both have to be checked and ensured that they satisfy the codal limits. Next query is from engineer Ketan Mahajan. He's from Jalgaon and he's a working professional. Uh, he's asking, I have seen some consultants applying EQ loads and selecting design overrides as non-sway. Is this okay? No, because if you are assigning it as non-sway, then the sway factors, effective length factors, will not be properly considered by the ETABs. I'm assuming you are running it on ETABs. So the sway factors will not be, so it will basically calculate Q if Q is more than 0.04, and if it becomes a case of sway, then also ETABs will continue assuming it as a non-sway frame because that is what the override you gave, and it will continue taking the effective length factors for non-sway frames. So this is not okay. This is okay only if you have already run the p delta analysis. Okay. So let's say if you have already run the p delta analysis in your software, that means the second order effects have already been considered. Then you might go for non-sway, sway, it will not matter because you have run the p delta. So the effects due to the sway will be considered in the p delta effects themselves. So then it might not be a problem whether or not to take the sway or non-sway frame. Okay. So just check the check it with your consultants that if are they including the p delta effects. If that is done, then non-sway sway will not be a problem. Okay. Also, I have seen them not providing any mass source and just applying the loads in load patterns. I think they must be using the default mass source. Yes. So in default mass source, ETABs will not consider the load patterns properly. So you might be using the default mass source, but then ensure that in the default mass source setting, you have set up the dead load plus some percentage of live load. So if that has not been done, then it's a problem. Okay. Yeah. Good. Today we have got interesting questions. The next query is from engineer Omkar Kulkarni. He's from Nagpur and he's an independent consultant. His question is, I have two queries. What does it mean when I say that I have torsion in my first mode? Does code anywhere mention that torsion should not be present in first or second mode? What do you mean when you say you have torsion in the first mode? That means the time period for the torsional mode is the largest, okay, or the frequency is the smallest. That means the structure will have the inherent tendency of the structure will be to have a torsional vibration when it is excited by a earthquake frequency. So what is the first mode? First mode is also called as the fundamental period of vibration. So that means whenever your structure has is getting excited by an earthquake, the tendency of the structure will be to oscillate in its first mode. Now, if that first mode is translational mode, that means the structure will have a tendency to translate when excited upon by earthquake frequencies. If the first mode is torsional, that means the tendency of the structure will be to oscillate, to have a in plan rotation when excited by earthquake frequency. So that is the meaning of first mode, first of all. Now, does code anywhere say that torsion should not be present? Yes. So if you refer to table 5, okay, why is problem? Let's discuss why is first mode of torsion is a problem, because if this is your plan view and let's say these are your vertical elements, having first mode as torsional means that when there will be an earthquake and when the structure gets excited, its tendency will be to rotate in plan or oscillate in plan about its center of rigidity. So what will happen? This will induce large shears in your vertical elements. Do you understand? A torsional mode will induce large shears in your vertical elements. If there are large shears in your vertical elements, what will happen? That it may lead to, what will happen if there is large shear in vertical elements? Tell me. Large shears in vertical elements will lead to a overall reduction in the compression capacity of your vertical members, because the concrete uh, may have a brittle failure due to this large shear. And if the concrete core, the confined concrete core undergoes a shear failure, it will affect the vertical load carrying capacity. And if the vertical load carrying capacity of your vertical members is affected, it will lead to collapse. So basically, that's why we don't want torsions to be the inherent. Uh, we do not want torsions to be the inherent behavior when it is excited upon by earthquake frequencies, and that's why it's undesirable. I'm not saying it's, you should not, I mean, it's undesirable. If it is there, you have to manage it, but it is undesirable for us. All right. Now, where does the code deal with this? So, if you refer to table 5, if you refer to table 5 of IS 1893, 2016, then it talks about the horizontal irregularities, and the first irregularity mentioned is the torsional irregularity. So then it sets out some parameters when a planned torsion may be allowed and when it cannot be allowed. It sets for some parameters. So for that, you can refer to table 5, and you can refer to the amendments to IS 1893 also. There are two amendments, Amendment 1 and 2. You may refer to them. And up to certain levels, the structure or the code rather allows the building to have planned torsion effects, but beyond a certain level, it does not allow you to have so. Okay, and then it needs revision in the structural configuration. So, for example, if your building shape is this, let's say this is your building shape, no amount of playing around with the configuration, no amount of playing around with the configuration will help you to remove the plant torsion effects. Understood? So, if your building shape is this, or if your building shape is some maybe some curve shape like this, it will be very very difficult and almost next to impossible to remove the plant torsion effects. So you can manage your configuration in such a way that the plant torsion effects are within limits, and those limits are given in table 5 of 1893 part 1 2016. Okay. Yeah. So I hope that also answers your last point, that adding shear walls away from the geometric center, but if architects don't permit, how to tackle. So as I just told you, you may have first mode as torsional mode, although it is undesirable. You may still have a system where the first mode remains torsional, but then it should not exceed the limits given in table 5 of 1893. Okay. Yes. Very good. So this was the query, and next query is from Engineer Kunal. He is from Muradabad and he is a faculty member. Uh, he is saying, that he has done his MTech in structural engineering, and he, due to family responsibilities, he has to uh, stay in a city and he cannot work outside the city. How can I start freelancing or remote work in structural engineering? If you could please suggest how to begin or which platforms to focus on. So, as I understand, you are already a faculty member. So, maybe you may have some design projects in your department itself for proof checking or for peer review. So, check with your college that do you have any design projects that come to you for checking, peer review. Maybe you can get involved in that. The other option can be look for some, let's say, consultancy firm in your city itself. I'm sure there must be some design consultancy firm, so you may join there as a part time to begin with, because you already have a job and responsibility of the family. So I will not suggest you to leave that job straight away. So what you can do is that as a part time, after your college work or after your primary duties are over, maybe you can go to uh, that design office and maybe just learn for 1 to 2 years. That will help you to learn the basics. I'm sure your basics are already good because you're, as a faculty member, you're already in touch with the basics. So start working in some design office as part time and work for 1 to 2 years. Maybe you have some friends or associates who have some design sites ongoing, project sites ongoing in your city. So try to get in touch with them. Maybe start visiting sites after your primary duties are over and spend some time on the sites. That way you will develop understanding. So if you do these things for 1 to 2 years, I think you will begin to understand, and then maybe you can take the next step. But don't take any step for at least 1 to 2 years until you have some confidence, until you develop some confidence in uh, the civil engineering field. Okay. Next query is from engineer Deva. He's from Hyderabad and he's a postgraduate student. So what he is asking, I think he had put a query on the WhatsApp group also. So let me have a look over there and let me also see what he had asked. Yes, so this is the query that he had asked. For walls with water table, how the pressures are applied to the walls from earthen side. We need to apply individually submerged pressure and water pressure, or we have to add all the pressures. So this we have discussed quite well in the course also. You have joined the liquidating structures course. We have discussed this in quite detail. So whether to apply submerged pressure, earth pressure individually, it will depend on the water table level. So whatever is your water table level with respect to your with respect to your tank level, that will decide how you apply your pressures. So let's say this is your ground level or uh, ground level, and your water table lies somewhere over here. So then, as per the tank depth, this is your water table, let's say. So above this, you will apply your soil pressures in the normal manner, and then below this, you will have the soil pressure plus the portion of the load that gets transferred from here, plus the water pressure loads. All these will have to be added below the water table depth. So this calculation has been well explained in the course on liquidating structures that you have already joined. Okay. So I request you to go through those sessions. You will understand. He had another query. Uh, when we increase the thickness of base slab, shear V3 is also increasing. Yeah, shears may increase because of the increasing stiffness. So it's not, I mean, it's not incorrect. Shears may increase because of the increase in the stiffness. It starts attracting more shear forces. So your shear values may increase, but then you are also getting increase in the thicknesses. So the increase in thickness that you get and the advantage that you get from it will exceed the increase in the shear that you are getting. So that means you have to constantly change the sizes, reanalyze, then check what are the outputs, then again make the changes and so on. Okay. So yes, it's possible that the shear forces increase with increase in the wall thicknesses because the stiffnesses are going up. There was another question put on the group by engineer Ravi Chandra Veluri. So he had shared this image and he had put this query, for which combination wall has to be designed for which combination wall has to be designed when consider only dead load and water, then the moment is higher compared with dead load plus live load plus SDL plus water. Yeah, so you have to design and check for each combination. What is the problem? You have to basically design and check for each combination all the reinforcements on whichever face you are providing. So there are four possible reinforcements in your wall: inner face vertical, outer face vertical, inner face horizontal, outer face horizontal. So each of these four reinforcements have to be checked for all possible load combinations, and the worst has to be ensured that for the worst effect, it has to be ensured that adequate reinforcement is provided. Okay, good. So these were the queries that were there on the Google. No, there's one more query. This query is from engineer Vinayak. He's a working professional from Bangalore, and he's asking. So what he's saying is that generally in the connections, let me just a minute. I'm just looking into something. Yeah, sometimes in the rafter to Z purlin connections, let's say this is my rafter and I have a cleat on the top of rafter. I will put some cleat, and then on this cleat, for the sake of ease of erection and simplicity, what we do is that when we put Z purlins, we have some gap between the Z purlins like this. So why we do it? For the sake of simplicity and ease. All right. So if we have a physical gap, it is easy to install the purlins, and then this is connected with bolts, and of course this cleat is connected with rafter. So there is a physical gap between the purlin bottom and the rafter. So right now, how the load transfer is taking place from, and let's say sheeting will be on top of this. So by doing this, what happens? It is easy to install the Z purlins this way. So the load transfer path will then become from purlin to your cleat to the rafter, and not directly from purlin to rafter. So his question is why there is a gap. So simple answer for this gap is the ease of installation on site. Second question is by providing this whether the purlin can provide restraint to rafter. Very good. So he is asking where is if this purlin is hanging in the air, can I assume that this purlin is providing restraint? Yes, you can still assume because this cleat is still in the because this cleat is still connected to the rafter. Okay, cleat is still connected to the rafter, and anyway for the lateral when there is a lateral dorsal buckling or flexural buckling, you will still get the restraint from the overall purlin system. Horizontal restraint is still being offered. So yes, you can still consider the purlin to be providing effective restraint to the rafter. And anyway, for the bottom chord, we do add flange bracings also. So yes, this can be done. This assumption can also be made. Clear? Very good. So these were the queries on the Google form. Now let us take the queries on the from the live audience. Uh, CE Srinivas is saying, I have messaged you on LinkedIn, hoping for a reply. Let me check the LinkedIn and message. Uh, so Mr. Srinivas Deshmukh has sent one message. So he is writing, I aspire to start my own firm as a structural engineer in the near future. I was earlier working in the BIM domain, but I have now returned to my hometown and wish to pursue my career here. At this stage, I feel the need for proper guidance and mentorship to move in the right direction. Uh, then he is further saying, I have been following your YouTube channel for some time now, and I truly admire your way of teaching and explaining concepts with clarity and practical insight. Thank you. Thank you for your appreciation. Your content has motivated me greatly and strengthened my interest in core structural engineering. I am very keen to learn under your guidance. I would like to join your classes and, if possible, seek your direction on how I should proceed from here, both in terms of technical skills and career planning, so that I can eventually establish myself as a competent structural engineer. So for this, what I would suggest is that, as I told you, as I was mentioning to another query earlier, that it is better that you first, because as you have worked in other companies already, but you that was in a different field, and now you want to work as a structural consultant. Earlier you were working in a company involved in BIM. So my initial suggestion would to you would be to work for 1 to 2 years under someone, and in your city, if you have any uh, consultancy firm, any practicing engineers in your city, then you should first of all start working under them, so that you get practical experience of doing projects. Secondly, if there are any associates that you have who have ongoing sites in your hometown, then start visiting those technical sites, and start to learn from what is happening on site. Do this at least for 1 to 2 years, or even 2 to 3 years, before you start your own firm. And if you want to join the courses, I'll be putting the WhatsApp link in this session. Just as we close today's session, I'll be putting the WhatsApp link, so you can contact me on WhatsApp, and we will guide you if you want to join any course that we have conducted. Okay? Yes. All right. Thank you for your message. And I'll be sending the WhatsApp link. You can connect it on WhatsApp. Then Engineer Rohit Kashyap, who had asked the first query of the day, he's asking. No, his was not the first query. One of the queries he had asked. So he is asking in shear walls and slabs, which bending and membrane modifiers need to be given the stiffness modifiers. So in shear walls, if this is the elevation of my shear wall, basically we want to have the in-plane moments modified. So in for in-plane movement, there is no direct option available in the ETAB shear wall. So what we do as an alternate option is to modify the F22 modifier or to give F22 modifier. By doing this, what happens that in a way the in-plane movements create tensions and compression couple in the 2-2 direction. So when we give F22 modifier, we are able to modify that stiffness. And in addition, you can give the M22 modifier in shear walls. Okay, because M22 modifier in shear wall will be the vertical out of plane movement. So for movements, these two modifiers can be given for the in plane and out of plane movements respectively. For slabs we design for the out of plane movements. So you can give the M11, M22 and M12 modifiers. Okay, good. Then nice. So we have completed the queries. So we have taken all the queries from the Google form. We have taken all the queries from the live comments also. Sorry, live comments also. There are no queries on the email and no queries on WhatsApp that have that are remaining for today's episode. So I'll just wait for a couple of minutes before closing today's session. Let me also check in the email. Yeah, no email received for query and no pending query on the Google form also. Yeah. So let's wait for a couple of minutes before closing today's session. If anyone has any more query, they may ask. We are waiting for a couple of minutes. Yes, please. Any queries? Okay, then. So I think then that's it for this session. No more queries. So as you all know that every week we conduct this session on weekend. So you can join and ask your queries. The Google form for asking the queries remains the same. So throughout the week, you can keep putting your queries in the Google form. And once every week when we meet, we will take up your queries. So this is the link to connect on the Google form. And if you want to send or if you want to connect with us on WhatsApp, then this is the link to connect on WhatsApp. So directly by clicking on this link, you can send a message on WhatsApp. So I'm just putting that link also. Yes. So this is the link for the this is the link to message us on WhatsApp. All right. So that's all for this week. Then we had a good session with lots of different questions from varied topics that were asked. So good. Keep on asking your questions, and let's continue having this interactive session that we have every weekend. So for this episode, that is all we have. Thank you very much for joining, and have a good week ahead. We'll see you in the next episode next weekend. Till then, have a good time. Bye bye.